What is the next step? Degree. Yes. What is the degree of this polynomial?
4.
How many solutions will you have to find? 4. Okay, perfect. What is the number of possible terms? So I'm going to write all this next to the chart. Degree 4. Max terms. The keyword is possible. 3. Very good. So how will you rearrange, or what will you do to the function to determine the x-intercepts? Squared. What is left? And I do have one more to add here to the list. Forgive me. The symmetry. Of course, this function crosses at -2, 0, and 3. It's not symmetric. But I don't want to forget that. That's important. It's part of the graph. Okay. So factor out x squared. What is left in parentheses? Good. How do I factor that?
-3.
If I put -3, very good. Perfect. Good. So what are the solutions? Remember, I need 4. How many times, and what is the multiplicity of 0?
0 2 times.
Very good. What does that mean? If 0 appears twice? Yes. What does that mean about the graph? Exactly. Absolutely. Remember x squared. X equals 0. Double solution. Term. Good. The other solution is 1, and the other solution is 2. What is the multiplicity for each? So I will write simple cross. You write whatever you want. As long as you don't forget what it means, I don't care what you write. But write something that triggers your memory, reminding you that la la la. Okay, what do I put under?
0.
I need to fill out my chart with the end behavior. What is the degree again? The options for 4 degree are 1 or 2. Identical with x squared. Very good. Why? Can anyone explain why we chose infinity to infinity? Because the positive leading coefficient. Very good. I'm done. I don't have anything else. I think it took less than 3 minutes. I will plot the x-intercepts. And now I will look at my chart and think for a moment. Ready? From positive infinity comes down to the origin, where it does what? Okay. So then it has to come up to whatever, but then it has to come down and cross at 1, 0. But then it has to turn again because it has to cross here, and it goes to infinity. Done. It's coming from positive infinity. It must turn at 0, 0. Has to come up to a maximum. It crosses, comes up to a minimum, comes down to a minimum. Done. And this is the function f of x, x to the 4th minus 3x cubed plus 2x squared. Yes, we do have 2 pieces of information that we are not able to determine, which is this and this. So I will have definitely between 0 and 1. Between 0 and 1 there must be a turn. And between 2 and 3, between 1 and 2 it must be a turn. These are the only pieces of information I cannot determine by hand. Everything else is done. And we haven't even done anything. Just, it took us what? Less than 3 minutes, right? So let's go to y equals, clear, and we plug in x to the 4th minus 3x cubed. 3x cubed. Oh, of course, I do that all the time. X to the 4th minus 3x cubed. And then it was plus 2x squared. Yes, yes.
So after putting the calculator, when I press second calc, can you help? How do I put in the minimum?
So click on minimum, and then you have to give the calculator a piece of the domain. So because this is not. So allow me to say something, and I'll come back right back. That is one of the reasons why I highly recommend graph the function from your understanding first. Because some graphs will look very weird on your graphing calculator. So this is one of them. Why? Because the x-intercepts are so close to each other. You may think that this is a flat here and it's on the x-axis. It's not. So do not trust the calculator. Okay. So I have to go and change the viewing window. The action happens between 0 and 2. So I'm going to say -2. Oh, of course. Sorry. Thank you. Sorry about that. Okay. From -2, let's say, to 4. With a scale of 1 is fine. I don't know how low I should go, but I already have the little picture here. So I'm going to say between -1 and 2. I didn't mean that. -1 and 2 with a scale of 1. And let's graph. Ah, and this is exactly what we expected. So that's why grabbing the calculator first to see the graph is not a good idea. Graph it first. So now when I determine this maximum, obviously I have between 0 and 1. When I determine this minimum is between 1 and 2. Is that okay? So change the viewing window, and then we
I'm saying, how do I, like, when you plug in?
Yes, yes. So so we go to second and calc. So we want to determine the maximum first. So that's fine. And then it's asking for the left bound. My left bound is 0. My right bound is 1. Why? Because I see the maximum is between x equals 0 and x equals 1. I don't want to guess. I just want the answer. Yes, one more time because there is no need to guess. So can you tell me what you got?
So it's 0.61 and 0.20.
So this is 0.61, comma 0.2. And this, which is the local min, in this case, is also absolute min. There is no other value lower than that. Okay? And this is another local min. 0, 0 is a local min as well. But I don't have to calculate that. I mean, put it with the calculator because I know that it's a term. Multiplicity 2, it must be a term. So now, do we have the minimum with second and calc? And I want the minimum, and the minimum is between 1, yes, and 2, yes. Give me the minimum, press again. 1.64, negative 0.62. Why? Right? 1.64, negative 0.62. Okay. So that's a perfect example in which I insist, do not trust the calculator. Do your work, understand what's happening there, and then check with the calculator because you have to for the max min. Any questions? Any questions?
If we did the quadratic like substitution on that, we'd come up with the same values, the 0, 1, 2.
Yes, if you use no, you cannot use
I mean,
you cannot use you cannot use this is not a quadratic in form.
there's only 3 terms.
Yes. Right. You have to factor out x squared. You have no choice here.
No, okay.
It's not quadratic inform.
Gotcha. If it was like, oh, right, if it was.
Right, because you have to have
I-
the middle term has to be squared and you get the first term.
Okay.
And it's not the case here. Okay, perfect. So any questions on how to graph polynomial functions? No problem, right? Okay, so let's refresh our memory on division of polynomials, and then we'll stop. This is a crucial topic for calculus. Understanding something very subdued in a way. It's not splashing water in our face. It's subdued and it's a very important topic. Okay, so first of all, let's take it slowly. Division of polynomials is of two categories. Category number one, a polynomial divided by one term, or also called monomial. This is the first category, and it's, you're going to say, what is this?
Wait, can you repeat that? What is it?
Yes, first category of division of polynomials. When I have a polynomial in the top, anything, and a monomial in the denominator, just one term. This can be 2, 3, 4, 5 terms, but this is just one. Okay, so let me list the other category in which I have a polynomial divided by a polynomial. Here there are two categories. Long division and synthetic division. Long division can be applied no matter what the denominator is, always. Whatever. However, the synthetic division cannot be applied all the time. It's specific, so synthetic division is limited in application. Synthetic division is specifically for a polynomial p of x divided by x minus a. Can anyone say anything about x minus a for me? What degree is this? Right. How many terms? Yes. A can be positive or negative. So the synthetic division works only if I have whatever over a binomial, definitely power 1. So it has to be a linear polynomial, power 1. And if I have a coefficient here other than 1, I will have to factor it out. Don't put it in the synthetic division. Okay, so we'll talk about that. Good, so let's start with the easiest possible. Let's say x cubed plus 2x squared minus 3 divided by x squared. This is the first category. Polynomial divided by one term. Let me beef it up with a 5 in front. So you don't think that it has to be just x.
-3.
Yes. The only thing I can do here, the only procedure allowed is separate the terms. X to the third over 5x squared plus 2x squared over 5x squared minus 3 over 5x squared. And I know you're going to say, but this is not division. I will have to agree, it's not. But that's the only thing we can do. So I will simplify each fraction by itself. The first fraction becomes either 1/5 x or x over 5. It's up to you. The second fraction becomes, yes? Yes, of course, 2/5. And the last one I can't touch. This is it. That's the most we can do. If you disagree with it, I will have to agree with you.
Is it answer?
There is nothing else I can do here. Now, dividing two polynomials. On page 251, please choose. I would like to choose, please choose number 14. Thank you. I need to show you an example like that. But thank you for choosing it. So yes, number 14 on page 251. So we have P of x over D of x, polynomial divided by divisor. And we have x to the fifth plus x to the fourth minus 2x cubed plus x plus 1. Everything divided by x squared plus x minus 1. Because I wanted to show the long division first, and then we go to the synthetic division. Okay. So this is category number 2. It's a polynomial over a polynomial, but is it the one that I can use the long division on?
Yes.
Yes. Can I use the synthetic division on this one? No, because the denominator is not a binomial degree 1. Perfect. Good. So this is definitely the long division. Okay. First step. Few questions. I'm asking myself a few questions. Question number 1. Is the top and the bottom, are these two polynomials in descending order?
Yes.
They are. They must be. If not, I have to rearrange them. Question number 2. Before I ask myself question number 2, I want to show you something that no one does anymore. Of course, I agree. Let's say I want to divide 5321 by 25. Yes, I'm going to grab the calculator, but exactly 2, and then I have to distribute or multiply 2 by 25. I do get 50, although it's positive. I change the sign, right? So 2 times 25 is not negative 50. But I have to subtract. So I'm changing the sign of that product into the opposite sign. Yes. Now I perform the operations. I see 3, nothing left. I bring down the next in line, 25 and 32, 1. I distribute 1 again to 25, and I write negative 25, although 1 times 25 is not negative. And then I have 7, and this is gone. And then I bring down the next in line, and that's 50. 2, very good. So 2 times 25, it's not negative 50, but I know I have to change the sign. So I get 21 with positive, right? How do I write the answer? 5321 divided by 25 is 212 plus, I need that for polynomials, plus the remainder over the divisor, which is 25, because I cannot continue. So this is the quotient. This is the remainder, which will be of x, because we have x in here. And this is the divisor. This is the original polynomial, and of course this is the divisor. Okay? The procedure is the same. Of course it will be strikingly different because there is x in there, but it's the same procedure. Okay, so coming back, my first question to myself is, can I use the long division or synthetic division? I cannot use the synthetic division. My second question is, are both in descending order? My third question, which I did not ask myself here, is, not for the bottom, but for the top. Is there a missing term from the top? And you can say, yes. What is the degree of the top? 5. All terms should be there. So degree 5 is there, degree 4 is there, degree 3 is there, degree 2 is not. I'm going to leave some room for it. Then degree 1 is there. What is the degree of 1? 0. Right? There is no x. Good. So let's start the same mechanism, step by step. So I'm dividing by x squared plus x minus 1. And the polynomial is x to the fourth plus, I'm sorry, x to the fifth plus x to the fourth minus 2x cubed space plus x plus 1. Here is my first question to myself. Should I write those 3 questions for you, or should I dictate them so you can write them? Those 3 questions are crucial. Question number 1, what type of division is it? It depends on the denominator, right? On the divisor. Question number 1, what type of division is it? Question number 2 that I asked myself is, are both polynomials in descending order? And the last question before I start the algorithm is there a missing term? That's it. Is there a missing term from the top polynomial only? Is there a missing term from the top polynomial only? These are 3 questions I always ask myself. Okay. So here's my next step. Should I repeat those 3 questions? Everything okay? Okay. Here's my question now to myself. X squared, like before. 25 times what is 53? 2. X squared times what is x to the 5th? Remember what I said with the 2 and the 1 a second ago? I go back and distribute. X to the 3rd times x to the 2nd power is x to the 5th, but I have to change the sign. Negative x to the 5th, and I have to write under like term. X cubed times x. I have to change the sign from whatever to the opposite and write below like term. Finally, x cubed times negative 1. But I have to write positive x cubed. And now I perform the operations I see. These 2 go away, these 2 go away. Negative 2x cubed plus x cubed is negative x cubed. I bring down the next in line. I don't know how many I need. I'm going to bring 3. I have to have 3, but we'll see in a moment what happens. Next question. X squared multiplied by what quantity is negative x cubed?
Negative x.
Perfect. I have to go back and distribute to all 3 terms, change the sign right below like terms. Negative x times x squared. Negative x cubed. Positive x cubed. Negative x times x.
Negative x squared.
But I have to write,
Positive x.
and that's why I need that space. Otherwise, I will mess up the whole thing. Negative x times negative 1.
Positive x.
But I have to write,
Negative x.
good. These are going away. These are going away. And what is left? X squared plus 1. I didn't mean to write that 1 there. You're very powerful. Don't tell me to write anything because I may execute. Okay, final question. How do I know it's a final question? Because these 2 have the same degree. It must be the final question. X squared multiplied by is x squared.
1.
I need sign and number.
Positive.
If I don't write positive, then I can distribute. So 1 times x squared is positive x squared. Change the sign. 1 times x is x. Right here. And 1 times negative 1 is negative 1, but I have to write plus 1. These 2 are gone. What is left as a remainder? Careful.
Plus 2.
Plus 2. So now, finally, here is my division. X to the 5th plus x to the 4th minus 2x cubed plus x plus 1 divided by x squared plus x minus 1. Please tell me what is the quotient. Perfect. X cubed minus x plus 1 plus, this is a must. You cannot write r, you cannot write something without the symbol. The numerator is the remainder, negative x plus 2, over what?
X squared plus x minus 1.
Any questions? I want to illustrate one synthetic division and I'll stop. I'm going to choose a simple one like 26. Last problem. On page 251. So we have x squared minus 5x plus 4 divided by x minus 1. Can I use a synthetic division here?
Yes.
Yes. Synthetic division requires us to put something in a little box. Requires us to put all coefficients even if they are 0. And requires us to draw a horizontal line like this. In the box, we always have little a. Can anyone identify little a? Little a is 1. Can anyone give us the coefficients? All of them, including the zeros. 1. Yes.
4.
Very good. The algorithm requires us to copy the first coefficient no matter what. The leading coefficient. 1 times 1. Yes, please.
What is a?
From the synthetic division, a minute ago, we wrote it as x minus a. This is a.
Oh, okay.
So, no, it's okay. So 1 times 1. Perform the operations and tell me what you get. Thank you. We continue multiplying. 1 times negative 4. And what is left in the box? When I divide, what degree is this? What is the degree of the polynomial?
2.
When I divide degree 2 by what degree I have in the denominator?
1.
What is the answer, the degree of the answer? Always.
1.
Right, degree 2 over degree 1. Right? So then, this has to have degree 1. Please dictate.
Thanks. Times 4. Okay.
Plus, if you want, I wouldn't. Plus what?
0.
Over?
Over x minus 1.
Yes. Of course we don't need this. Because the remainder is 0.